Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. I'm sorry for any kind of noise you might be hearing. Some work is going on beside my house. I'm really sorry for that. Anyway, so this is part 5 video on the chapter Congruence. In this video, I will solve the problem number 5 to 10 from exercise 16. If in the previous video, part 4, I solved the exercise 16 problem number 1 to 4. If you have not watched the previous 4 videos on the chapter Congruence, I highly suggest that you watch them to maintain the continuity of your study on this chapter Congruence. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then please I strongly suggest and request that you please support me by subscribing to my channel. Also, please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have all the questions written down on the canvas from question 5 to 10. I will solve question from 5 to 10 from the exercise 16 in the textbook of author RS Aggarwal. So let's get started. So we have a figure. It is said in this figure AB is equal to AC, okay, and BD is equal to DC. So the equality of the sides AB and AC are shown in the figure by single line, and the equality of the sides BD and DC are shown with double lines. It is asking to prove that triangle ADB is congruent to triangle ADC and show that angle ADB is equal to angle ADC equals to 90 degree and angle BAD is equal to angle CAD. Now this is a very common property that in an isosceles triangle, since AB is equal to AC, if we consider the triangle ABC, it's an isosceles triangle where AB is equal to AC, and if you draw a perpendicular from the vertex A on the side BC, then AD will bisects the side BC. Anyway, so let's solve this problem. So what do we have? We have to consider the triangle ABD and ADC and locate the 3 matching parts and see which 4 congruence conditions it is satisfying. That is it SSS or SAS, ASA or RHS. Now clearly what information we have in hand, we know that for triangle ADB and triangle ADC, we have what we have is AB equals to AC. We have AD as a common side. We have common side. Also, it is given that BD is equal to DC. BD is equal to DC. So we can see we have 3. These are the 3 matching parts. First matching part is side. Second matching part is also side, and third matching part is also side. So we are having S congruency property. SSS congruency property is satisfied, and hence we can say that the triangle ABD and ADC is congruent. Now we have to prove that we have to find the correspondence. We know that. So we have AB equals to AC, and now note one thing, that if there is a common side between 2 triangles and we have established a congruency between them, then the vertex, the endpoints of the common side are those vertices will be will be the corresponding vertices. I mean, since AD is common side, clearly is common side, this will imply that A of triangle ADC is mapped to A of triangle ADC. Sorry, this will be ADB. The vertex A and vertex D are the common vertices of the triangle ABD and ADC. So we can say the triangle vertex A of the triangle ADB is mapped to A of the vertex A of triangle ADC. Also, we can say that D of triangle ADB is mapped to D of triangle ADC. So clearly, so this will imply the only vertices left is B. So we can clearly say that B is mapped to C. Hence, we know the mappings in the we know the mappings of the vertices ABD in triangle ADB to the vertices ADC of triangle ADC. So this will imply from the mapping of the vertices, we can clearly say the triangle ADB is congruent. The correspondence will be vertice A and D are the common the vertices of the common side, so they will remain as same, and B will be mapped to C. So this is proved based on the SSS congruence property. Since three sides of the triangle ADB are equal to the corresponding three sides of the triangle ADC. Now it is asking to say, so this will imply we can say that triangle angle ADB will be equal to angle ATC, and since these two angles are linear pair, linear pair of angles, as they lie on the same side of the straight line BC at the point D, and that angle ADB plus, so their sum of linear pair of angles is always 180 degree. We know that angle ADB plus angle ADC is equal to 180 degree. So these two will imply, if you solve it, you will get angle ADB is equal to angle ADC is equal to 90 degree. And also from this, since these two triangles are congruent, we can say that now so BD is equal to DC, we can say that the angle opposite to BD, we can say that the angle opposite to the side BD, which is angle BAD, should be equal to the angle opposite to the side DC in triangle ADC, which is CAD. So this is proved. We have first proved that triangle ADB is congruent to triangle ADC, and now we know from this, from the congruency of the two triangles, we know all the sides will be equal, all the corresponding sides will be equal, all the corresponding angles will be equal. Now we know that BD is equal to DC, and the angle opposite to BD in triangle ABD is angle BAD. So that should be equal to the corresponding angle in the triangle ADC, which is angle CAD, because it is the opposite angle of the side DC in triangle ADC. Okay, I hope it's clear. Question number 6. So in this figure, in triangle ABC, we have triangle ABC. AD is the bisector of angle A. Okay, AD is the bisector of angle A. If AD is perpendicular to BC, so that triangle ABC is isosceles. Okay, meaning we have two isosceles. Okay, two sides of triangle ABC must be equal. Okay, now we will consider the triangle ABD ABD and triangle ADC. What we have, AD is the common side, AD is the common side. It is given that AD is the bisector of the angle A in triangle ABC, which will mean that BAD, angle BAD is equal to angle CAD, and is also given that AD is perpendicular to BC. So we have angle ADB is equal to angle ADC, which is equal to 90 degree. So we have three matching parts. This is a side, this is an angle, and this is a right angle. So definitely we have to use the RHS congruence property. What is RHS? Now, okay, no, sorry, we cannot use RHS yet, because the hypotenuse in the triangle ADC, hypotenuse is this. This is the hypotenuse. This is the hypotenuse, and for triangle ABD, the hypotenuse is AB, and we do not know yet whether AB is equal to AC or not. So let's say this is H dash. So what property of congruence we can apply from these matching parts to ensure that these two triangles are congruent? We have side, angle and angle. Angle and angle. We cannot really consider these as a right angle, but let's say this be angle. So we have AAS. The only option we can have is ASA. Can we have this? Angle, side, angle. That is, this are two angles and the side included by the two angles. What do we have? We have this angle, common side, and 90 degree. So this is 90 degree. Now, so we have, we can see that AD angle BAD and angle ADB includes the side AD in triangle ABD. Similarly, we can say that CAD and angle ADC includes the side AD in triangle ADC. So the three matching parts, we can see the three matching parts are two angles and the side included between them. Hence, we apply the ASA congruence property, which is angle side angle, that is the side included between the two angles. Hence, we can say, now we have to see the correspondence. What will be the congruence relation between the triangle ABD and ADC? Now, we know, now let's try to understand, find out the correspondence of the vertices. Now clearly, this is very similar to the previous problem, because AD is the common side, so definitely the vertices A and the vertices D are common to both the triangles. Those will be mapped among themselves, and B will be mapped to C. So definitely we will have triangle ABD congruent to triangle ACD. In the previous problem, ADB is okay. It's fine. I can also say, or I could have also said triangle ADB is congruent to triangle ADC. Both are fine. Okay, so I have this. Now the problem is show that triangle ABC is isosceles. Now from this, since these two triangles are congruent, we can say that now this will imply all the corresponding sides of the two triangles will be equal. Also all the corresponding angles of these two triangles will be equal. Now let's see what is now we can see that AB is a AB and AC are the two sides of triangle ABC, and we clearly, now this will imply, we can say that AB is equal to AC. From the congruence relation of triangle ADB and triangle ADC, we can say that the length of the side, the length of the AB, the side AB of triangle ABD will be equal to the side AC of triangle ADC. This implies triangle ABC is isosceles, because AB and AC are the two sides of the triangle ABC. Okay, hence proved. Okay, question number 7. So in this figure we have two triangles, ADC and ABD, ABC and ADC. In this figure it is given AD is equal to AB, which are shown with single line, and CB is equal to CD, which are shown with double lines. It is asking to prove that triangle ABC is congruent to triangle ADC. Now clearly we can see that AC is the common side. We can show with 3 lines. So for triangle ABC and triangle ADC, what we have, AC is the common side, or is a common side, so definitely is the common side, and also AD is equal to AB, and CD is equal to CB. So we have side, this is a AC is the common side, this is a, so it's a, the matching pair is a side. AD is equal to AB, this matching pair is also about is side, and this is also side. So we have clearly S congruence property applicable, and so we can say that the two triangles ABC and ADC are congruent. Now we have to find the correspondence between the triangle ABC and ADC. Clearly, since AC is a common side, AC is the common side, AC, let's say this is triangle ABC. Since AC is the common AC is the common side, we will have A and C will be same, and B will, then definitely in triangle ABC the B has to correspond with the vertex D of triangle ADC. So we have D. So this is the congruence relation between the two triangles ABC and ADC. Now prove that. Okay, so we have hence proved. So this was easy based on the 3 sides are given. We can see the 3 sides are equal in the two triangles. The 3 sides are equal, and just from the equality of the 3 sides, we have to find the correspondence between the two triangles, and then we have to we have to correctly write the congruence relation or congruence name between the two triangles. Okay. Problem number 8. In this figure, PA is perpendicular to AB. Okay. QB is perpendicular to AB, and PA is equal to QB. So these sides is equal to these sides. PA is equal to QB. Prove that triangle OAP is congruent to triangle OBQ. Okay. Is OA equal to OB? Okay. So we can see we are given that, let's say let's consider the triangle for triangle AOP and triangle OBQ. We are considering these two triangle AOP and OBQ. OAP and sorry, this is, let's say this is B. It doesn't matter. I mean, just to name a triangle, I can use any ordering of the letters. So let it be, no problem. Let's say AOP, and let's say this B. Right here, I am not at all concerned about the correspondence or the congruency. I am just referring the triangles. So in just referring a triangle, I can use any ordering of the vertices, letters. Let's say this is BOP, BOQ. Now for these two triangles, we know that these are the opposite, vertically opposite angles. They has to be same. So we have angle AOP equals to angle BOQ. We have this. What else is given? PA is perpendicular to AB. Therefore, angle OAP will be equal to angle OBQ, because BQ is also perpendicular to AB. They are equal to 90 degree, and also it is given PA is equal to QB. So we got three matching parts, and let's see if this can be, if this falls under any four conditions of congruence conditions, that is SS, ASA, RHS or SSS. So this is an angle, this is an angle, this is a right angle. So we have two angles and one side. So definitely RHS will not work. RHS is one right angle, one hypotenuse and one side. So two sides and one angle. Right angle, hypotenuse and side. Even though the angles OAP and OBQ are right angles, but we do not have two sides. We have two angles and one sides. So RHS will not be applicable in this problem. So angle. So angle, it is, we are having angle side, and the only option, only congruous condition we can think of is ASA. That is this angle side angle, that is the side, two angles and the side included by the two angles. Are we having that? Are we having that? This side we are having AP this side. This is an angle, this is an angle, but this angle, angle OAP, angle AOP is not really, angle AOP and the right angle is not including the side AP. So this is not working. This is not, this is not working. So we have to think find some other matchings. So what we can do is the vertically opposite angles is not helping us. We have this right angle, this is fine, and we have a side. So we have to somehow consider this angle. In this triangle AOP, we have to consider this angle, and we have to prove somehow, and also see in the triangle BOQ, this is the side, BQ is the side, and the right, we are having the right angle at B. So definitely this angle, we have to consider this angle, so that it will fall under the category two angles and the side included by the two angles. How do we prove that APO is, angle APO is equal to angle OQB? Now see that PA is perpendicular to AB and QB is perpendicular to AB. From the parallel lines, properties of parallel lines and angles, you must be familiar that if this is the case, this will imply that PA is parallel to QB. If two lines are perpendicular to another line, then those two lines are parallel to each other. We have PA parallel to QB, and clearly, and we also have AB, not AB, we have PQ. We have PQ is a transversal, transversal to the parallel lines PA and QB. So this will imply the alternating internal angles, interior angles will be equal. So this will imply angle OPA should be equal to angle OQB, as they are opposite interior angles, Okay, so now we have to now consider the three matching parts as PA equals to QB, this OAP is equal to OBQ, and OPA equals to OQB. These are the three matching parts. This is angle. So these are the three matching parts using which we can apply the ASA congruence condition, because in the triangle AOP, the right angles, that is angle A and the angle OPA, is including the side AP or PA. Similarly, in triangle BOQ, the right angle at B and the angle OQB is including the side BQ, and we already have PA equals to QB, and so we already know that. So the two sides of triangle AOP and its including angle is correspondingly equal. We can see that now. So the fact that PA is equal to QB, angle OAP is equal to angle OBQ, and angle OPA equal to OQB, these three matching parts will imply a congruence property, because the three matching parts are in this so we have three. So these are the three pairs of matching parts, and we can see that in each pair. So we can see that for each triangle, the matching parts are two angles and its included side, and hence we can apply the ASA congruence property and say that these two triangles are congruent. And what will be the congruence relation? We see that angle A is equal to angle B. We see that angle A is equal to angle B. This will definitely imply that A will have a correspondence with B, and we see angle P. We can see angle P, which is basically angle OPA. Angle P is equal to angle OPA is equal to angle OQB, which is Q. This will imply P has a correspondence with Q, and so the only vertex left is O, and O is definitely the common vertex in two triangles, so it will remain the same. So these three mappings of the vertices will imply that triangle AOP is congruent to triangle BOQ. AOP is congruent to triangle BOQ, but it has or we can say, since we know the correspondence of the three vertices of the two triangles, we can say, because it has asked to prove OAP, so I can also say triangle OAP is congruent to triangle A is mapped to B and Q. So this is what it has asked to prove. Triangle OAP is congruent to triangle OBQ. Now is OA equals to OB? Now this will imply, since the two triangles are equal, we know that AO, this will imply from the congruence relation of the two triangles, we can say that the side AO is has a correspondence with the side OB. So we can say from this congruence relation, we can say that OA has a correspondence with OB. This will imply, of course, that these two sides has to be equal. These are corresponding sides, has to be equal. So we get OA equals to OB. This is what it has asked to prove. OA equals to OB. Okay. So while I am solving the problems, you can pause the video and take a screenshot for your future reference. Okay. Let's do problem number 9. Okay, so in this figure, triangle ABC and triangle ADC are right angled at A and D respectively. Okay, and AC is equal to DB. AC is equal to DB. Prove that triangle ABC is congruent to triangle DCB. Now, whenever you in the problem of congruency of triangles, if two triangles in the two given triangles, if you see both the triangles are right angled, and then do not immediately try to apply the RHS rule, because for that you have to have the two hypotenuses to be equal. In this problem, if we do not have the fact that the hypotenuses, oh, indeed the hypotenuses are equal, because hypotenuse is the common side of the two triangles. Okay. Okay, fine. So you have to before applying the RHS, make sure that the hypotenuse of the two triangles are equal. As you know that what RHS stands for, one right angle, the right angle. Of course, since the two triangles are right angle, that will be same. Hypotenuse should be same, and one arm should be same. And we can clearly see in the triangles ABC and BD, DCB, the common side is the hypotenuse to both the triangles. So hypotenuse is the same. So for triangle ABC and triangle BDC, what we have is angle A is equal to angle D is equal to 90 degree. BC is the common hypotenuse. BC is the common hypotenuse, and it is given AC equals to DB. It is given AC equals to AC is equals to DB. Now this is right angled. This is hypotenuse, and this is an arm or side, an arm. So clearly we can see RHS congruence property can be applied, because as you can see, for the triangle we are having the three pairs of matching parts are the right angles, that is the angle A is equal to angle D. They are both right angles. Angle A is from triangle ABC and angle D is from triangle BDC. The hypotenuse, both the hypotenuse are same, because the hypotenuse is the common side. BC is hypotenuse to both the triangles, so we have H. And we can see in triangle ABC, the arm AC is equal to the arm BD in triangle BDC. So we have the side RHS. So now let's see, try to see the correspondence, the congruence, the correspondence of the congruence, the correspondence between the two triangles under which we can let's try to find a correspondence between the two congruent triangles. We have already proved that these two triangles are congruent. Now it has asked to prove that triangle ABC is congruent to triangle DCB. So let's see how the vertices of triangle ABC are mapped to triangle BDC based on the congruence results. So A is equal to angle D will imply that A has to map with D. Okay. Now BC is the common side. BC is the common side. This will imply that B will itself map to itself and C will map to itself. Even though this may look weird, but this is a fact, because B and C are common vertices of the two triangles. So this will imply that triangle ABC, the congruence relation will be A is mapped to D. So D and B and C will remain same. So we have ABC, it is given ABC is congruent to DCB. ABC, DCB. A is mapped to D, that is for sure. The A is the right angle in triangle ABC and D is the right angle in triangle BDC. So there, the vertex A has to map with vertex D. Now, we have BC is the common side. BC is the common side, so can't we say that BC is the common side? Okay, now this is not working. This logic, I'm sorry, this logic is not working. If in the two congruent triangles one side is common and so one side is common, so the vertices, endpoints of the side should have a correspondence with themselves. Maybe this is not working because it has asked to prove that ABC is congruent to triangle DCB. Okay, let's see. So what else we have? We have AC equal to dB. AC is equal to dB, and we know already that A is mapped to D. We already found that A is mapped to D. Now since A is mapped to D and we have AC equals to dB, so A is mapped to D. So from the fact that AC is equal to dB and that A is mapped to D, we must have C mapped to B. Okay, so this is why we are having this implies that C has a mapping with B. I'm sorry. So this is a proper logic. If you have two angles equal, if you have a correspondence between two angles and a correspondence between two sides where the sides have the letters of the angles, then you may apply this logic. That is, if you have a correspondence between A and D, vertex A of triangle ABC has a correspondence with vertex D of triangle BDC, and also we know that AC equals to dB. Then from AC equals to dB, you know that A is already mapped to D, so definitely C has to map with B. So A is mapped to D, C is mapped to B. So in triangle ABC, the only vertex B has to map the leftward vertex in triangle BDC, which is C. So this implies we will have triangle ABC is congruent to triangle A is mapped to D, B is mapped to C, and C is mapped to D. Hence it is proved. Okay. So always this is a very important concept that you may apply for getting a correspondence, for finding a correspondence between two vertices. So you see that AC is equal to dB. AC is a side from triangle ABC and dB is a side from triangle BDC, and also I know that the vertex A is mapped to vertex D. Now, so in this AC equals to dB, you know that A is mapped to D, so the remaining vertices will be mapped to themselves, that is mapped to each other, that is C will be mapped to B. Okay. Question number 10, we have in this figure ABC is an isosceles triangle in which AB is equal to AC. So AB is equal to AC is given. If E and F be the midpoints of AC and AB, if E and F are the midpoints of AC and AB, okay, respectively, prove that BE is equal to CF. So we are given AB equals to AC. Also F is the midpoint. F is midpoint of AB. This implies BF is equal to FA. Also E is midpoint of AC. So this will imply EC is equal to AE. BF is equal to FA. Also we can say, since F is the midpoint of AB, so BF is equal to FA is equal to AB by 2. Since F is the midpoint of AB, similarly we can say EC is equal to AE is equal to AC by 2. This implies, since AB is equal to AC, we can say that BF is equal to EC. Prove that BE is equal to CF. BE is equal to CF. Now try to identify with which two triangles you need to work for congruency that will help you to prove that BE is equal to CF. Now BE, for BE you can consider, so we can consider the triangle BEC, and CF you can consider the triangle BFC. Even though there are more triangles, I think these two triangles will help us to solve the problem. So in triangle, let's see, so see in triangle BFC and triangle BEC, let's see what matching parts do we get. We have we got BF equals to EC. We have BC is the common side. BC is the common side. So we have two sides. So definitely two sides. So the congruence properties are SAS, SSS, SAS, ASA and RHS. So we already have two sides. So definitely and we do not see any right angle forming. So we are not sure whether these two triangles are right angled or not. It is very important in this kind of problem to wisely choose the two triangles. It will depend a lot how quick you can solve the problem if you can choose the two triangles correctly. I have chosen the triangle BEC and BFC. Now BF is equal to EC, BC is a common side, and what else do I get? Now angle B is equal to angle C, but that is not helping. Angle B, angle C are not angles of the triangle BFC or BEC. This is a midpoint. AB is equal to BC. So this AF is equal to AE. AF is equal to AC. AF is equal to AE. How about if we consider the triangle ABE and triangle not ABE but prove that BE is equal to CF. Okay, BE is equal to CF. these are the midpoints. Okay. Also, what we are having, AB is equal to AC. We are also having BF is equal to EC. BF in the triangle BFC and BEC, we have found two sides to be equal. We have found these two sides are equal. This is the common side for the triangle BEC and triangle BFC. Now, can we? No, we cannot. We cannot actually prove now. So we have to think of any angles. So oh, okay, sorry, yes, it is. We can. We are also having in this in triangle BFC and triangle BEC, we can see that angle B is equal to angle C, because in triangle ABC it is given AB is equal to BC. That will imply AB is equal to BC. AB is equal to BC. This will imply that the opposite angles are equal. That is, angle C is equal to angle B. And we can also see that angle B is also an angle of the triangle BFC, and angle C is an angle of the triangle BEC. So we have, this is a side, this is a side, and this is an angle. So in triangle BFC and triangle BEC, we got three pairs of matching parts as SSA. The only option that we can apply is SAS. Now we have to see whether we can apply SAS, that is the three matching parts in a triangle, are there two sides and the angle between them angle included by the two sides. Yes, it is, because in triangle BFC, BF and BC includes the angle B. This angle is included between the sides BF and BC. Similarly, we see that in triangle BEC, EC and BC, EC and BC includes the angle C. So clearly we can, so this fact, so we have BF equal to AC, BC is the common side, and angle B is equal to angle C. So these are the three matching parts, and this is falling under the category of SAS, that is two sides and the angle included between them. So this information clearly implies we can apply SAS congruency. So this will imply, now the two triangles are congruent. Now we have to correctly name the congruence relation. So we see that, so we can say that angle B is equal to angle C. So angle B, so this will imply B must have a correspondence with the vertex C, as the angles B is equal to angle C. What else do we have? Also we see that BF, also we have BF equals to EC, and also we found that B is mapped to C. So B is mapped to C. It is, we have already established. So definitely F should map to F. So this implies F has a mapping with E, and hence the congruence relation will be if I consider the triangle BFC will be congruent. B is mapped to C, F is mapped to E, and C is mapped to B. So this is the congruence relation we are having, triangle BFC congruent to triangle CEB. Now from this, so we know that the corresponding sides and the angles should be equal, and this so this implies that BF BF must have, the side BF must have a correspondence with the side CE. BE. Okay, BE, BEC, and BFC. What is the congruence relation we got? We have to prove BE is equal to CF. Okay. So from this we can say that we have this congruence relation. Now BE is equal to CF. BE is equal to BE. How come BE is equal to CF? What are the triangles here? BFC, BFC, BFC and BEC, BFC and BEC. Okay. We have to prove BE is equals to CF. We have to prove BE equals to CF. Okay. Now, CF is a side from the triangle BFC, and BE is a side from the triangle CEB. Now, from this congruence relation that triangle BFC is congruent to triangle CEB, let's find out this will imply CF, the side CF from triangle BFC must correspond to the side BE of triangle CEB, because we have to prove BE and equals to CF. So CF is a side from triangle BFC. So if I want to find out which side in triangle CEB has a correspondence to the side CF in triangle BFC, I will see that C has a mapping with B. So, and F has a mapping with E. So CF will be must have a correspondence to BE. This will imply if these are the two corresponding sides in two triangles, then of course their length should be equal. So we have CF equal to BE. Hence it is proved. So this brings to an end in solving the questions from question number 5 to 10. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the remaining problems, that is problem 11 to 15, I guess. I don't know how many questions are there. I will solve the remaining problems in the next video, that is part 6. So please stay tuned for the next video where I will solve the remaining problems. And once the exercise 16 is complete, I will prepare 2 practice test papers as I do for all chapters, which will have questions not from the textbook but from other sources, those will be a bit harder and tricky, and those problems will definitely give you a good foundation of your concepts on the chapter Congruence. And once those practice test papers 1 and 2 are complete, I will start the series of videos on concepts to remember. I have already recently completed the series of videos of concepts to remember for the chapter properties of triangles. If you have not watched them, watch those videos. I highly suggest that you watch those videos. It is in the same playlist, that is CBSE Math 7 RS Aggarwal. So thanks for watching, and until the next video, take care and bye.